Welcome, this is Ad Emmen reporting for Premier Magazine from the ISC Cloud and Big Data Conference in Frankfurt. We're talking here now with Alexander Wolf, who is project coordinator for the Harness project. Welcome.
Thank you. I'm a professor at Imperial College London, and I've had the privilege of coordinating this project for the past 3 years. Today happens to be the last day of the project, but I'm very proud and very happy with the results of the project. The goal of the project was to develop a set of principles for how heterogeneous resources, things like GPUs and FPGAs and ASIC-based routers, could be integrated into the cloud platform. What we've been able to do is demonstrate through an advanced architecture that's been integrated with OpenStack how we can, let's say, hide the peculiarities of these resources at the same time as leveraging their advanced features. And the result is much better performance for a variety of difficult applications: scientific computing, stream data processing, and even MapReduce, traditional sorts of cloud processing systems.
Okay, thank you. So it's a European project, or it almost was a European project. How many partners were involved?
We have 6 partners, including, aside from Imperial College, University of Rennes, EPFL in Switzerland, and we had an industrial partner, SAP, you may have heard of, and another industrial partner, which was an FPGA company in London, Maxeller. They sell a very interesting data flow engine device for accelerating applications. And finally, we had ZIB, the Zuse Institute, which is a supercomputer center in Berlin.
Okay, thank you. One of the things that you said during your presentation, you just presented the Harness project during the conference, was that accelerators, if you have an accelerator, it's not enough to put your program on it just to get it faster. You need to do something more.
Right. One of the interesting things we found was that accelerators do not always accelerate a program. In fact, sometimes they can run slower. So you have to be very careful about how you manage and decide whether to schedule a particular job for an accelerator.
Yeah. Okay, thanks. And and if you schedule it for a certain accelerator, you also showed that sometimes you could do part of the programs on the accelerator, part on the GPU, etc.
Exactly. And so being sensitive to which portions of an application are appropriate for acceleration was a very fundamental part of the project. And what we did was we built a system which can do automatic performance modeling to allow you to show which portions of the program would benefit from acceleration. And that led then to an automatic scheduling mechanism to schedule the use of the resources when an application came to the cloud.
So people don't have to do the programming and scheduling themselves. You provide the system for that where that can be more or less automatically done.
Right. Now, we did assume in the project that different implementations of components would be provided for the different heterogeneous devices. It's reasonable because there's a lot of work going on in programming of these devices, but the actual act of scheduling these tasks for the devices and doing that automatically was the challenge for the project.
Okay. If people want to use your system, can they do that, or is it available?
Well, the goal of the project, since it was a small European project, was to demonstrate the ideas. We have a working system, as I said, integrated with OpenStack, and you certainly can find out more about it by going to the Harness website. I think what's important to understand is that the world is becoming more heterogeneous, that our computing platforms are going to be more and more diverse, and until we have systems that can handle that diversity, we won't be able to really take good advantage of that wonderful technology.
Thank you very much for that message.
Thank you.
For Premier Magazine, this was Ad Emmen reporting.